Question number 52. A two-dimensional non-negative continuous random variable xy has the joint density fxy 4xy e to the power minus x square plus y square. Let t square equals to x square plus y square. Then the density function of t is given by. So we are given t square and we are asked to find the density function of t here. Now let us write the joint distribution, joint PDF. The joint PDF is given by 4xy e to the power minus x square plus y square. So this can be written as 2x e to the power minus x square into 2y e to the power minus y square. This can be written like this. Now we know one distribution that is called Rayleigh distribution. If x follow Rayleigh distribution with parameter sigma, then the PDF of x is given by x upon sigma square e to the power minus x square upon 2 sigma square, and x is greater than 0 here. So if we put sigma square equals to 1 by 2, in that case the PDF of x becomes x e to the power minus x square into 2. Now if we compare this PDF with this one, so we can say that x is a Rayleigh random variable and y is also a Rayleigh random variable. So x follow Rayleigh with parameter 1 by 2 and y also follow Rayleigh with parameter 1 by 2, and their joint density function is equals to the product of their marginal densities. So x and y are independent. X and y are independent because the joint density function is equals to the product of their marginal densities. So if x follow Rayleigh distribution, that means x square will follow exponential distribution with parameter 1 upon 2 sigma square, and y will square of y square will also follow exponential distribution with parameter 2 upon sigma square. So here x follows exponential with parameter 1. Why? Because the value of sigma square is 1 by 2. So this 2 will get cancelled with 2. So we will get parameter as 1. Also, y will follow exponential distribution with rate parameter 1. Now, x square follow exponential distribution, y square follow exponential distribution, and they are independent. So the sum will follow gamma distribution. X square plus y square will follow gamma distribution. Now we are summing up two random variables. So the shape parameter n will be 2 and the rate parameter lambda is 1. Okay, because of this one and this one. So we have that t square, which is equals to x square plus y square, follows gamma distribution with shape parameter n equals to 2 and rate parameter lambda equals to 1. So we can say that t square follows gamma distribution with n equals to 2 and lambda equals to 1. Now, we do not need to find the distribution of t square. We want the distribution of t here. So, suppose suppose this t square is equals to a random variable u. Okay, so this u will also follow gamma distribution with parameter 2 comma 1. Now, what will be the PDF of u? Fu of small u equals to. Okay, we know that if x follows gamma distribution with shape parameter n and rate parameter lambda, then the PDF of x is given by lambda to the power n upon gamma n e to the power minus lambda x into x to the power n minus 1, right? So we have on the place of lambda we have 1, on the place of n we have 2. So the PDF will be e to the power minus x into x upon 1, because the value of gamma 2 is 1, right? So this will be the PDF. So if we write the PDF of u, on the place of x we have small u, so this will be u into e to the power minus u. Obviously u is greater than 0 here. Now we need to find the PDF of square root of u. Suppose v is equals to square root of u, because u is equals to t square, and if we take square root of t square we will get t, and this t will be equals to the square root of u. So we need the PDF of square root of u here. So what we can do here, we can do little bit transformation here. So from here this problem changes to a transformation problem. Now we can write that small v equals to small under root u. From here we can write u equals to v square. Now why we are separating u here? Because we have the PDF of u and we want to find the PDF of v. So whenever we have PDF of a random variable, we take it on the numerator in the derivation, and if we are finding the PDF of v, we take it in the denominator like this one. So if we differentiate it here with respect to v, we will get 2v. Now what will be the PDF of v? The PDF of v will be fu of, now wherever we have u in the PDF of u, we will replace it by v square. Why? Because u equals to v square. Then we will multiply it by this derivative du upon dv. Obviously we will take the absolute value. Now on the place of u we have to write v square because of this one. e square into e to the power minus v square. So this part is done. Now we need to multiply with the absolute value of du by dv, that is 2v. So this will give us 2v cube e to the power minus v square. So this is the PDF of v. So on the place of v, we can put t here. This will give us 2 t to the power 3 e to the power minus t square, because v is equals to square root of u, and square root of u, and u is equals to t square, so v will be equals to t. That's why we have written t on the place of v. So if we match this one matches with option A. Option A will be correct.